Good morning. I'm Padmapriya, Assistant Professor in Department of CSE, RMD Engineering College. Today we are going to see the topic tree under the subject data structures. Tree is a hierarchical data structure defined as a collection of nodes. It is a non-linear data structure. It represents the values, node represents the value, and the nodes are connected by the edges. Now let us see this diagram. In this diagram, all the diagram which is being represented within a circle is going to be called as nodes. And the lines which are being connecting all these circles is going to be called as edges. In any tree with nodes, n nodes, there will be a maximum of n minus 1 edges. And in a tree, every individual element is going to be called as node. In this tree, there are 11 nodes and these nodes are being connected with 10 edges. Tree. Root. In a tree data structure, the first node is going to be called as a root node. Every tree must have a root node. Root node is the origin of the tree data structure. And in this diagram, A is the root node. In any tree, the first node is going to be called as root node, from which all the other nodes are emerging. Edge. Connection between one node and to another is going to be called as edge. It is a line between two nodes or a node and a leaf. In a tree with n number of nodes, there will be a maximum of n minus 1 number of edges. So in this diagram, the lines which has been connecting the nodes A and C, C and H, and so on, these are going to be called as edge. Parent. The node which is the predecessor of any node is going to be called as a parent node. Here, A, B, E, C, G are going to be called as parent nodes. In any tree, the node which has a child or a children is going to be called as parent. And any node which is a predecessor of any other node is going to be called as parent. So for B and C, the parent is A. For D, E, F, the parent is B. For G and H, the parent is C. For I and J, the parent is E. For K, the parent is G. Child. The node which is the descendant of any node is going to be called as child. The node which has a link from its parent node is called as a child node. Here, B and C are the children of node A. G and H are children of C. K is the child of G. D, E, F are the children of B. I and J are children of E. Siblings. The nodes which belong to the same parent are called siblings. The nodes with the same parent are called as sibling nodes. So in the diagram, D, E, F are the siblings because all the three nodes have the same parent B. I, J are the sibling because both of them, the parent are E. G and H are siblings as they have common parent as C. For B and C are siblings. For them, the parent is A. So as I told you, D, E, F are siblings, G, H are siblings, B, C are siblings, I, J are siblings. Leaf. The node which does not have a child is called a leaf node. A leaf is a node with no child. Here, D, I, J, F, K, and H are leaf nodes. So those nodes does not have any children, so it is going to be called as leaf nodes. So node without any successors is called as a leaf node. Internal nodes. The nodes which are at least one child is called as internal nodes. An internal node is a node with at least one child. Here, A, B, E, G, C are internal nodes as they have at least one child. And every non-leaf node is called as internal node. Degree. The total number of children of a node is called as a degree of that node. The degree of a node is the total number of children it has. The highest degree of a node among all the nodes in a tree is called as the degree of the tree. Now, for degree of B is 3. For degree of A is 2. Degree of F is 0. So for any node, the number of children it has represents the degree. So the highest degree of this node of any node in this tree is B. which has 3. So the degree of the tree is going to be 3. Level. In a tree data structure, the root node is said to be a level 0, and the children of a root node are at level 1, and the children of the nodes which are at level 1 will be at level 2, and so on. So the root node is always at the level 0. The next level, B, C is at the level 1, D, E, F, G, H at the level 2, I, J, K are at the level 3. In a tree data structure, the total number of edges from a leaf node to a particular node in the longest path is called as the height of that node. In a tree, the height of a root node is said to be the height of the tree. In a tree, height of all leaf node is going to be 0. So here the height of the tree is going to be 3, as the height of the root node is 3. So the height of the node is the total number of edges from the leaf to the node in the longest path. So now let us consider B. So from B, the longest path to the leaf node is going to be B to E, E to I. So it is going to be 2. For C, it is going to be C to G, G to K. And another one path is C to H. So we have to take the longest path. So for C, the height is going to be 2. That is from C to G, G to K. For K, the height is going to be 0, as the K is going to be the leaf node. Now for A to B, B to E, E to I. So the height is going to be 3. Path. In a tree data structure, the sequence of nodes and edges from one node to another node is called as a path. The length of a path is the total number of nodes in that path. In the example, the path A, B, E, J has length 4. So the path is a sequence of nodes and edges between two nodes, and path between A and J is going to be A, B, E, J. Path between C and K is C, G, K. In a tree data structure, the total number of edges from the root node to a particular node is called as a depth of a node. In a tree, depth of root node is 0. The highest depth of any leaf node in a tree is said to be the depth of that tree. So the depth of the tree here is going to be 3. In any tree, the depth of the node is the total number of edges from the root to that node. So the depth of the tree is the total number of edges from the root to the leaf in the longest path. So the depth of the root node A is going to be 0. The depth of the B is going to be 1. So from the root node A to B, the path is 1. Number of edges is 1. Now for G, the depth is going to be 2, as from A to C, C to J, the number of edges is 2. Now for K, the depth is going to be A to C, C to G, G to K. So the depth is 3. So the leaf node is going to be considered the depth of the tree. So for I, J and K, the depth is going to be 3. So the depth of the tree is going to be 3. Subtree. In a tree data structure, each child from a node forms a subtree recursively. Every child node will form a subtree on its parent tree. So for A, there are two subtrees, left subtree and right subtree. B, D, E, F, I, J forms the left subtree. C, G, H, K forms the right subtree. For B, there are D, E, F. So for E, there is again left subtree and right subtree. So I and J. Thank you.